Welcome back to Unusual GCSE Questions. This time we've got this classic question from Edexcel Higher, June 2017, paper 1, question 22, right at the end of the paper. Confused everybody back in 2017, so we're going to have a look at how it works. So I'll put the proper question on the screen now for a few seconds so you can look at it, pause it, have a go at it, and we'll be back. Right, okay, so what we've got is a trigonometry question that's on a non-calculator paper that looks, on the face of it, a little bit scary, doesn't it? It's not so bad, right? It's not as bad as it looks. Nothing's ever as bad as it looks. So, we've got to prove that something to do with angle PBQ. Now PBQ is not currently marked on the diagram, so I'm going to mark it up. So let's draw in, oh that's terrible, right, let's draw in that line, and then we'll draw in this line. We're given a little bit more information in the question. BP and BQ are both 10. Let's put that in. And angle ABC, which is that angle, is 30 degrees. That's what we've got to work with. And we've got to show this. And the problem you might be having with this question is where do you even start? So, there's some clues. One clue is that it says cos. Now, the only time you see cos in GCSE maths is in basic Socaterra right angle triangle work. It doesn't look like no obvious right angle triangles in there. Or the cosine rule. Now, if we're going to use the cosine rule, let's just remember that for a minute. We're trying to make an equation. Now, you might have heard me say on other videos that if you're trying to make an equation, what you've got to do is go look on the diagram and find two things that are equal and set them equal to each other. It sounds obvious, doesn't it? It's an equation, you've got to find two things that are equal. Okay, so what about if we say, can you see we've got two triangles through here? We've got triangle ABC and we've got triangle PBQ. And what's equal is their bases, isn't it? That's what is equal. I've been told it says AB and BC, they're called X. Right, that's where X is going to come from. Let's put that in. Right, so now let's use the cosine rule. So AC and PQ. So what we're going to say is that we're going to use the fact that AC is equal to PQ. So what are AC and PQ? Well, if we were going to try to find out, we could use the cosine rule on triangle ABC. Okay. So let's say that AC squared, so equals x squared plus x squared minus 2 times that, cos 30. 2 times x, that's x squared, cos 30. I haven't written the cosine rule down. I imagine you've got access to the cosine rule. I'm just aware that this is probably going to take up most of the board. I don't want to waste space. So what have we got? We've got AC squared is x squared plus x squared, that's 2x squared minus 2x squared cos of 30 degrees. Now you should know this, sine of 30 is a half and sine of 60 is the square root of 3 over 2. You get that from the little triangles, remember? So from our little triangle, 1, 2, root 3, 60, sine of 30 is a half, cos of 30, root 3 over 2, and then with 60 it's the other way around. So sine of 60 is root 3 over 2, cos of 60 is a half. Anyway, cos 30, root 3 over 2. And at this point I can cancel out those 2's straight away. Okay. Don't forget, you can't combine those x squareds with these x squareds. That's a common mistake with cosine rule. This 2x squared is attached to the cos 30. You can't just put those together. Right, let's do the same thing with triangle PBQ. So now we've got PQ squared equals 10 squared plus 10 squared. So that's 100. Let's call it 10 squared plus 10 squared minus 2 times 10 times 10. Let's call it 2 times 10 times 10 times by cos of PBQ. Okay. Let's tidy this up. 10 squared is 100, so this is 200 minus 200 cos PBQ. Can't combine this 200 with this 200 because this is attached to cos PBQ. Right, now, if AC is equal to PQ, then we can say that AC squared is equal to PQ squared, can't we? So if that is equal to this, then this is equal to this. This is where we're going to go with this. So I've got 2x squared minus the square root of 3 times x squared. And that is equal to this, 200 minus 200 cos PBQ. Now what we have to do, all we have to do now is rearrange this formula to make cos PBQ the subject, and we should get this. Let's see. Right, so see the x squared is outside of the bracket. You use the thing that you're trying to make as a guide as to what to do. So if I take x squared out here, I've got that. You can see we're making this thing. Now the 200 is separate. Let's thing is, right, I don't really want to, I factorise out 200. No, let's factorise out 200. 1 minus cos. In some ways, it doesn't matter what you do as long as you don't make a mistake. Now, if I divide by 200, both sides, okay, we're basically there, aren't we? I just need to add cos PBQ to both sides. That will get that to kind of move over to there. The 1 stays where it is. And now I bring that bit over to the other side. I'll move the x squared to the other side of the bracket so it matches what we're trying to do. And there we go. It's not as bad as it looked. What can we learn from this question? Get good at algebra. Practice the cosine rule. Remember with the cosine rule that you can't join that with this. That bit is separate to this bit. Very common mistake. What other facts did we need to know? If two positive things are equal, then their squares are going to be equal. If two negative things are equal, their squares will be equal. That's not what we're doing. And originally, if you don't know where to start, look for two things that are equal and just write an equation that says that they're equal. And we'll follow it through, you'll get there. Have a bit of confidence. When a question looks difficult, it's not as difficult as it looks. So, yeah, any bits you don't understand, ask questions in the comments. Any other hard questions you want us to look at, unusual questions, also leave that in the comments and I'll make some more videos.